Okay, in the last video, we actually set this up and we basically compared it to a coordinate system. So that's similar to what I want to do now. You can see that I have a coordinate system right here, okay? And this coordinate system, basically, we have our X, we have our Y. I'm just going to slide this over. You see we have our X and we have our Y. If you guys remember, maybe you do, maybe you don't, if I just play this, you'll see that our video is basically a rod rotating about a pivot point. And we're trying to keep our origin set at the pivot point. So let me go ahead and go back to this particular picture. Now, let's use some fabulous colors here. So again, this is our origin right here, and definitely want to use my script pen. So this is the origin right here. So we set that origin. We have our X and we have our Y axis. So our X axis is horizontal. Our Y axis is vertical. Okay. And we also, so what's happening at this origin? Why do we call it the origin? Well, it's because right here, this is actually going to be 0, 0. So X and Y, and it's hard to see that because of whatever, X and Y equals to 0, 0 at this location. Okay, let me rewrite that. It's just too light. Or it's the wrong color. So I'll try black. So X and Y, which are ordered pairs, equals to 0, 0 at this location. All right, that's the idea. So as we move out along the X-axis, it's going to increase. As we move up, it's going to increase as well. If we go down, it'll increase in the negative direction. If we go out this way, it'll increase in the negative direction for the horizontal axis. Now, we have tick marks along this axis, okay? And they're going to be calibrated according to 10 centimeters. You'll remember that we have our calibration rod here. We set our pixels. This is our pixel rod, pixel calibration rod, and it equals to 0.1 meters. That is 10 centimeters. There are 100 centimeters in a meter, so 10 of them is a tenth of a meter. So we have 0.1, 1 over 10. It's the same thing as 0.1, okay? I think that's all I need to talk about on this. Now we're going to start and we're going to set some points, and we're going to watch this rod rotate around this axis. So essentially, we are going to, let me find a nice bright red here. We're going to set a point right here, and then this, as soon as we set a point, this rod will move, and then we're going to set another point, and then it'll move again, and we're going to set another point, and another point, and another one, and another one, and another one, and another one. So it's going to look similar to this, and each one of these points is a different X and Y, okay? So we're going to use X and Y to describe some functions here, and the first function will be sine of theta, okay? And sine of theta, just, if you look back at the theory, the axiomatic theory for vectors, you'll see that we define sine of theta as y over r. It's really just the y, the opposite side to the angle over r. So if we have a triangle here, this is a point. If this is y and this is x and this is our angle theta, it's the opposite side, whereas x is the adjacent side. And r is a calculation based on Pythagorean's theorem. And we're going to have cosine of theta as well. That's just going to be x over, not y, but r. And then we'll have tangent of theta, and that's going to be y over x. So these are the functions that we want to define, and the only thing that we're going to use to define these functions will be the following. Y over r, x over r, and y over x. So all we need to know are the ordered pairs. Once we know the ordered pairs, we can calculate r. Once we calculate r, we can calculate sine of theta, cosine of theta, and tangent of theta. That's pretty much it. All right, so let's go ahead and get out of this.